You all, this is the solution video to a week 3 assignment of C Programming Assembly Language 2023 NPTEL course. Let's start off with question 1, where we have this macro defined like so, right? So the point is to go and find the usage of this word macro everywhere in the C code and replace it by this definition. And as you can see here, macro is being used. This statement will be interpreted as so, and we can then see that the A is a string called macro, and that was what will be printed over here in the printf statement. So the correct answer is macro equal to macro for question 1. In question 2, yeah, so as I explained before, the answer is A, right? And it happens in the pre-compilation phase. The correct answers are A and B. A follows from the lecture videos, and for why B is correct, if we again refer to statement 1, you can see that it is a hash include of studio.h, which has the definition for the function printf. And so if you don't have it, this function will not be declared, let alone defined, and therefore you'll have an error, or you'll have an error in the compilation phase, right? In the following code, we have a declaration for the function callee underscore one, but we don't have a definition for it. So therefore, you won't have a compiler error. You'll have a linker error. In this function, there are no errors in this function. We have a in this C code, you have a function which returns a value, which returns an int value, and you're just calling it in main. So the above code is not erroneous. Now over here you have a function being called, but it is neither declared nor defined, and so you will just get a compiler error itself. Now looking at question 7 onwards, we are given a code, right? And we are also given the compiled assembly for this code, basis which we are asked to find the asked to answer questions 7 to 17, right? So first let's look at question 7. With respect to the main function, what is the minimum value of n naught, right? So let's look at n naught, right? So n naught is what we need to create the local variable space, right? N naught is what you need to create the local variable space, and three variables z, y, and dummy2, right? So each short is 2 bytes, so that is 3 variables into 2 bytes per variable, so that's 3 bytes, 6 bytes, right? So the answer is 6. So 6 is the minimum value of n naught, right? But it might depend on the way the compiler is set up, how much local variable space is actually allocated. That's why we've given the minimum value of n naught. The compiler at least has to allocate so much of local variable space. The in statement 13 of the C program, you have this function call, right? And we are asked how this function call translates into assembly statements, right? And the assembly statements are given as n1, n2, n3, which I've given over here for reference. And you can see that the you can refer to the lecture notes, but you'll find that the push will happen in this order, right? And so n1 will be 7, n2 will be 6, and n3 will be 5, and that is the answer. So for question 9, we are asked what will happen when the statement C306 finishes executing. That is after the call has finished and it goes into the function, and after it returns back. That is after C512 what happens, right? So for this, let us look at the execution flow of this entire assembly code, and we'll see what happens, right? So I'll skip directly to the point where the call happens, right? So what all happens? So this is the statement that we are looking for, C306. What I'm showing you here is the status of the stack after this statement has finished executing. So maybe we'll look at the statement just before this, right? So after push n3, right? After after push n3 happens, you have the stack pointer pointing to the top of stack over here, right? And the values of 7, 6, and 5 have been pushed onto stack. The immediate next statement after that is call, right? And during call, what all happens, right? So if you remember from the lecture video for call does, push EIP, and then EIP is the, if you're calling some location, call space location address, it first pushes EIP onto the stack and then makes EIP as the address that you do the call for, right? So that's what happens over here, right? So first question is, what is this ADDR underscore 1? ADDR underscore 1 is the address of the first statement in the surface area function, right? So if we refer to the question statement, this address is ADDR1, right? The calling address, right? So C500, right, will be the address that is called, right? So that is the first part of the correct answer. ADDR1 is C500. And so what happens? So when you do call of 0xC500, first you have the EIP of C307, right? C307 is the immediate instruction after C306. That is what the EIP has, and that will get pushed onto stack, right? So ESP then goes up, and next what happens? EIP gets the value of C500, right? And now you are in the C500 execution, right? And I'll go, so in later questions, I'll go over the exact flow in this execution, but we'll just skip to the point where we have to return from this function call, right? So for question number 9, we just have to skip to the point where we are returning from the function call. So the last few statements are move reg2 comma reg1. So this is move esp comma ebp, right? And by doing that, you now have esp equal to ebp, and then you have to pop reg1. And what is reg1? Reg1 is ebp, right? So reg1 is ebp. And so yeah, you've got EBP referred back to the local variable space of the previous guy, right? And then you have return 0. What does return 0 do? Return 0 does pop EIP, right? Yeah. So return 0 does pop EIP, and that is what this will do. And you will be able to see that EIP is C307. And because you've done pop EIP, you can see that the stack has gone down to here, right? Because you've done one pop, the stack ESP reduces again, and you've got ESP pointing back to C307 address, right? So the address of EIP is ESP is now to so if you now search for what is the what ESP itself points to, it will be C307, right? So ESP itself has this address, But then what is in the memory location pointed to by ESP? That is this, and that is C307. That was the original EIP that was pushed on to stack when you did the call function, when you did the call. So that is the second half of the answer for question 9, right? Now for question 10, right? Question 10 refers to the the context switching when you come into a function call, right? So you can see that you have reg1 and reg2. We know from the lectures that these are the relevant statements, right? Reg1 and reg2. We know from the lectures that reg1 is EBP and then reg2 is ESP. So first you push the original local variable space address uh, in a statement of push EBP, and then you move ESP to you move EBP equal to ESP to start of the new local variable space, right? So that is the answer. Reg1 is EBP and Reg2 is ESP, right? And at this point, I am simply going over step by step what the main. So this is the main function, and this is and over here is the surfare function, right? And I have marked the steps 1 2 3 4, and I've given the same number and also the statement over here. So what I'll do, I'll go over this slowly, right? And you can pause the video at any point to try and work it out yourself, right? And as I go over this, the relevant questions for the relevant step will also be answered at the appropriate time, right? So the first step is push EBP, right? So whatever was EBP originally is now pushed onto stack, and ESP is moved to 4 bytes above, right? And then we have move EBP. So this is the context switching for main, right? Move EBP comma ESP, right? And then we have sub ESP minus N0. Like we discussed, N0 is 6, right? At the very minimum, N0 is 6. And so we have ESP going to start minus 10, right? This is for creating the local variable space for main. Then we have push N1, N2, N3, right? Which are the parameter passing, right? For the function call of surfare, right? Then we have the actual call, right, of C0x C500 for the surface area function. And during the call, EIP will get pushed onto stack, right? And then EIP will be loaded with the ADDR underscore 1, right? So now the execution flow has gone to ADDR underscore 1, and we have yeah, we have the first statement, which is push EBP, right? This is basically the EBP, right? Which is yeah, the original EBP value was start minus 4, so that start minus 4 is now pushed, right? Then move EBP comma ESP, right? This is the context switching, and now again local variable space creation for the surface area function, which is so, right? Huh. And then so question 11, the answer will be 4, right? Because now there are 4 bytes. There are 4 bytes, that is 2 short variables, surface area and dummy, right, over here. Then question 12, so that is the minimum value of n5, right? Sub ESP comma n5. What is n5 was question 11. Then question 12 is with respect to the surfare function, what is the value of qual? Now for N4, so for the move qual pointer EBP minus N4, this refers to the, so remember EBP minus refers to local variables, EBP plus refers to passed parameters, right? And what is the qualifier for local variable here? They're all short, right? If you remember the C function, the variables are all short variables, and so the qualifier is a word pointer, right? And so that's the answer there for question 12, right? And in question 13, what are the values of the integers n7, n6, n7, and n8, right? So these refer to the past parameters length, breadth, and height, right, over here. And you can see the values for them, and therefore uh, right, and get what n6, n7, and n8 are, right? So yeah, so basically now we are at the point where we've created the local variable space for the surface area function, and then we have uh, uh, if you see over here, I have given the execution, like what the relevant execution in terms of the C variables is for the assembly program. You can pause the function just to see if it makes sense, right? Right. And then now in so statement 9 onwards, again we have already discussed this, but I'll go over this one more time. We are now at the end of, so all of this has now executed the program, right? Has executed the surface area calculation using length, breadth, and height, right? And we are now at C510, right? After after fin- so after finishing C50F, we are now at C510, and we have to get the context back. We have got the value to be, we have obtained the value that needs to be returned, and we need to switch back to the uh, main function call, right? Taken care of by C510, right? Move ESP comma EBP. This we've already discussed what Reg2 and Reg1 are, right? So ESP will be equal to EBP now. Now you've set the, you remove the local variable space in the next statement, sorry, in the next, we now get EBP back to the local variable space of the original function, that is start minus 4. And yeah, with this return function, the now with this return function, EIP will get the value of C307, right? And ESP is now pushed, one down because of the pop that happens inside return 0. And add ESP comma val2, right? So what is val2? Val2 is the is what we need to bring ESP back away from the uh, parameter passed, push statements. So now, what is val2? It is what we are adding back to ESP, right? So it now depends on how these parameters were passed. We will allow two answers. One which is 6, right? Where does the 6 calculation come from? It comes from 6 is equal to 3 into 3 variables are there and 2 bytes per variable, or 3 into 4 bytes per variable. It depends on the way the compiler does it, right? In this working out example, I have given it as 2 bytes per passed parameter, but in some cases you can also see it as passed as 4 bytes, and so we will be allowing both 6 and 12 as answers over here, right? For question 15, you can see what the value of val1 is, right? So val1 is, because we want to now do, so the formula is 2 into length lb plus bh plus lh, right? So that 2 into is coming over here, right? And so that value of val1 is the shift left. So shift left is multiplication by 2, right? And so val1 is shift left by 1 is multiplication by 2, and so val1 is 1, right? SHL is shift left. So in question 16, the correct answer is underscore C double convention, right? And in question 17, the correct answers are A, C, D, and E, right? This just follows from the explanation of the function that you can refer about, right? So now for questions 18 to 20, we have the below C++ program, right? You can have a look at question 18, right? Which of the following assembly statements which of the following will be the assembly statements corresponding to which statement 5 compiles to, right? So over here I have statement 5 highlighted. You can see that it compiles to the following four statements, right? And this will and all these three are included in that, right? Next, statement 10 in the C++ code, right? You can refer here. I've highlighted statement 10 and also the statements which it will compile to, right? And so you can see there are only 1, 2, and 3 in there, right? Yeah. Then we have question 20. When statement 14 compiles, it translates to the following, and what is val, right? So, so you can see that there is nothing subtracted from EBP in statement 25, and so therefore the answer is 0.